Nvidia CEO Jensen Huang explained at CES that the next big step for AI goes beyond generative or even agentic AI. The future lies in physical AI, which involves self-driving cars and general robotics. This evolution represents the next major leap in AI technology.
AI is physical AI. Model performance is directly related to data availability, but physical world data is costly to capture, curate, and label. Nvidia Cosmos is a world foundation model development platform to advance physical AI. It includes auto-regressive world foundation models, diffusion-based world foundation models, advanced tokenizers, and an Nvidia CUDA, an AI-accelerated data pipeline. Cosmos models ingest text, image, or video prompts and generate virtual world states as videos. Cosmos generations prioritize the unique requirements of AV and robotics use cases, like real-world environments, lighting, and object permanence. Developers use Nvidia Omniverse to build physics-based, geospatially accurate scenarios, then output Omniverse renders into Cosmos, which generates photoreal, physically based synthetic data. Whether diverse objects or environments, conditions like weather or time of day, or edge case scenarios. Developers use Cosmos to generate worlds for reinforcement learning AI feedback to improve policy models, or to test and validate model performance. Even across multi-sensor views, Cosmos can generate tokens in real time, bringing the power of foresight and multiverse simulation to AI models, generating every possible future to help the model select the right path. Working with the world's developer ecosystem, Nvidia is helping advance the next wave of physical AI.
Huang emphasized the need for a world foundation model for robotics, similar to how large language models serve as foundational models for natural language. Nvidia aims to build this through its Cosmos model, which would provide the data and frameworks necessary to train advanced robotic systems.
Physical AI. So, physical AI. Imagine, whereas your large language model, you give it your context, your prompt on the left, and it generates tokens one at a time to produce the output. That's basically how it works. The amazing thing is this model in the middle is quite large, has billions of parameters. The context length is incredibly large because you might decide to load in a PDF. In my case, I might load in several PDFs before I ask it a question. Those PDFs are turned into tokens. The basic attention characteristic of a transformer has every single token find its relationship and relevance against every other token. So you could have hundreds of thousands of tokens, and the computational load increases quadratically, and it does this, all of the parameters, all of the input sequence, process it through every single layer of the transformer, and it produces one token. That's the reason why we needed Blackwell. And then the next token is produced when the current token is done. It puts the current token into the input sequence and takes that whole thing and generates the next token. It does it one at a time. This is the transformer model. It's the reason why it is so incredibly effective, computationally demanding. What if instead of PDFs, it's your surrounding? And what if instead of the prompt, a question, it's a request? Go over there and pick up that box and bring it back. And instead of what is produced in tokens as text, it produces action tokens. Well, that I just described is a very sensible thing for the future of robotics. And the technology is right around the corner. But what we need to do is we need to create the effectively the world model of, as opposed to GPT, which is a language model. And this world model has to understand the language of the world. It has to understand physical dynamics, things like gravity and friction and inertia. It has to understand geometric and spatial relationships. It has to understand cause and effect. If you drop something, it falls to the ground. If you poke at it, it tips over. It has to understand object permanence. If you roll a ball over the kitchen counter, when it goes off the other side, the ball didn't leave into another quantum universe. That's still there. And so all of these types of understanding is intuitive understanding that we know that most models today have a very hard time with.
Physical AI lags behind large language models mainly due to data limitations. ChatGPT, for example, is trained on trillions of text samples. To get humanoid robots to function well, we need vast amounts of robotic and environmental data. Nvidia's Project Isaac and Isaac Sim are key tools they're using to collect and scale this data, accelerating the capabilities of physical AI.
Developers around the world are building the next wave of physical, AI-embodied robots, humanoids. Developing general-purpose robot models requires massive amounts of real-world data, which is costly to capture and curate. Nvidia Isaac GR00T helps tackle these challenges, providing humanoid robot developers with 4 things: robot foundation models, data pipelines, simulation frameworks, and a Thor robotics computer. The Nvidia Isaac GR00T blueprint for synthetic motion generation is a simulation workflow for imitation learning, enabling developers to generate exponentially large datasets from a small number of human demonstrations. First, GR00T Teleop enables skilled human workers to portal into a digital twin of their robot using the Apple Vision Pro. This means operators can capture data even without a physical robot, and they can operate the robot in a risk-free environment, eliminating the chance of physical damage or wear and tear. To teach a robot a single task, operators capture motion trajectories through a handful of teleoperated demonstrations, then use GR00T Mimic to multiply these trajectories into a much larger dataset. Next, they use GR00T Gen, built on Omniverse and Cosmos, for domain randomization and 3D to real upscaling, generating an exponentially larger dataset. The Omniverse and Cosmos Multiverse Simulation Engine provides a massively scaled dataset to train the robot policy. Once the policy is trained, developers can perform software-in-the-loop testing and validation in Isaac Sim before deploying to the real robot. The age of general robotics is arriving, powered by Nvidia Isaac GR00T.
We're going to have mountains of data to train robots with. Nvidia Isaac GR00T. Nvidia Isaac GR00T. This is our platform to provide technology elements to the robotics industry to accelerate the development of general robotics.
Nvidia showcased how AI is already transforming factory operations. By simulating various processes, factories can become more efficient and productive. This is a glimpse of how integrated AI will revolutionize multiple sectors of the economy.
Kion, the supply chain solution company, Accenture, a global leader in professional services, and Nvidia are bringing physical AI to the $1 trillion warehouse and distribution center market. Managing high-performance warehouse logistics involves navigating a complex web of decisions influenced by constantly shifting variables. These include daily and seasonal demand changes, space constraints, workforce availability, and the integration of diverse robotic and automated systems. And predicting operational KPIs of a physical warehouse is nearly impossible today. To tackle these challenges, Kion is adopting Mega, an Nvidia Omniverse blueprint for building industrial digital twins to test and optimize robotic fleets. First, Kion's warehouse management solution assigns tasks to the industrial AI brains in the digital twin, such as moving a load from a buffer location to a shuttle storage solution. The robot's brains are in a simulation of a physical warehouse, digitalized into Omniverse using OpenUSD connectors to aggregate CAD, video and image to 3D, LiDAR to point cloud, and AI-generated data. The fleet of robots execute tasks by perceiving and reasoning about their omniverse digital twin environment, planning their next motion and acting. The robot brains can see the resulting state through sensor simulations and decide their next action. The loop continues while Mega precisely tracks the state of everything in the digital twin. Now, Keon can simulate infinite scenarios at scale while measuring operational KPIs, such as throughput, efficiency, and utilization, all before deploying changes to the physical warehouse. Together with Nvidia, Keon and Accenture are reinventing industrial autonomy.
That's incredible. Everything is in simulation. In the future, every factory will have a digital twin. And that digital twin operates exactly like the real factory. And in fact, you could use Omniverse with Cosmos to generate a whole bunch of future scenarios, and you pick, then an AI decides which one of the scenarios are the most optimal for whatever KPIs, and that becomes the programming constraints, the program, if you will, the AIs that will be deployed into the real.
The future of autonomous driving is expanding quickly. Companies like Waymo provide excellent driverless experiences, and Nvidia is positioning itself to be a major player in this space. As driverless systems improve, we can expect smoother, quieter rides that could reshape how we travel and live in our cities.
Next example, autonomous vehicles. The AV revolution has arrived. After so many years, with Waymo's success and Tesla's success, it is very, very clear autonomous vehicles has finally arrived. Well, our offering to this industry is the three computers: the training systems to train the AIs, the simulation systems, and the synthetic data generation systems, Omniverse and now Cosmos, and also the computer that's inside the car. Each car company might work with us in a different way, use one or two or three of the computers. We're working with just about every major car company around the world: Waymo and Zoox and Tesla, of course, in their data center, BYD, the largest EV company in the world. JLR's got a really cool car coming. Mercedes has a fleet of cars coming with Nvidia starting this year, going to production. And I'm super, super pleased to announce that today, Toyota and Nvidia are going to partner together to create their next generation AVs. Just so many cool companies, Lucid and Rivian and Xiaomi, and of course, Volvo, just so many different companies. Wabi is building self-driving trucks. Aurora, we announced this week also that Aurora is going to use Nvidia to build self-driving trucks. Autonomous, 100 million cars built each year, a billion vehicles on the road all over the world, 1 trillion miles that are driven around the world each year. That's all going to be either highly autonomous or, fully autonomous coming up. And so this is going to be a very large industry. I predict that this will likely be the first multi-trillion-dollar robotics industry. This business for us, notice in just a few of these cars that are starting to ramp into the world, our business is already $4 billion, and this year probably on a run rate about $5 billion. So really significant business already. This is going to be very large. Well, today we're announcing that our next generation processor for the car, our next generation computer for the car, is called Thor. I have one right here. Hang on a second. Okay, this is Thor. This is Thor. This is a robotics computer. This is a robotics computer. It takes sensors and just a madness amount of sensor information, process it, umpteen cameras, high resolution, radars, lidars, they're all coming into this chip. And this chip has to process all that sensor, turn them into tokens, put them into a transformer, and predict the next path. And this AV computer is now in full production. Thor is 20 times the processing capability of our last generation Orin, which is really the standard of autonomous vehicles today. And so this is just really quite incredible. Thor is in full production. This robotics processor, by the way, also goes into a full robot. And so it could be an AMR, it could be a humanoid robot, it could be the brain, it could be the manipulator. This processor basically is a universal robotics computer. The second part of our drive system that I'm incredibly proud of is the dedication to safety. Drive OS, I'm pleased to announce, is now the first software-defined programmable AI computer that has been certified up to ASIL D, which is the highest standard of functional safety for automobiles. The only and the highest. And so I'm really, really proud of this. ASIL D, ISO 26262. It is the work of some 15,000 engineering years. This is just extraordinary work. And as a result of that, CUDA is now a functional, safe computer. And so if you're building a robot, Nvidia CUDA, yeah.
Finally, Nvidia's use of digital twins allows AI to train on countless realistic scenarios, far beyond what any human driver could experience in real life. This means autonomous vehicles will learn from and be tested on thousands of potential road situations, ultimately becoming much safer and more reliable than the average human driver.
The autonomous vehicle revolution is here. Building autonomous vehicles, like all robots, requires 3 computers: Nvidia DGX to train AI models, Omniverse to test drive and generate synthetic data, and Drive AGX, a supercomputer in the car. Building safe autonomous vehicles means addressing edge scenarios, but real-world data is limited, so synthetic data is essential for training. The Autonomous Vehicle Data Factory, powered by Nvidia Omniverse, AI models, and Cosmos, generates synthetic driving scenarios that enhance training data by orders of magnitude. First, OmniMap fuses map and geospatial data to construct drivable 3D environments. Driving scenario variations can be generated from replayed drive logs or AI traffic generators. Next, a neural reconstruction engine uses autonomous vehicle sensor logs to create high-fidelity 4D simulation environments. It replays previous drives in 3D and generates scenario variations to amplify training data. Finally, Edify 3DS automatically searches through existing asset libraries or generates new assets to create sim-ready scenes. The Omniverse scenarios are used to condition Cosmos to generate massive amounts of photorealistic data, reducing the sim-to-real gap. And with text prompts, generate near-infinite variations of the driving scenario. With Cosmos Nemotron Video Search, the massively scaled synthetic dataset, combined with recorded drives, can be curated to train models. NVIDIA's AI Data Factory scales hundreds of drives into billions of effective miles, setting the standard for safe and advanced autonomous driving.
Isn't that incredible? We take thousands of drives and turn them into billions of miles. We are going to have mountains of training data for autonomous vehicles. Of course, we still need actual cars on the road. Of course, we will continuously collect data for as long as we shall live. However, synthetic data generation using this multiverse, physically based, physically grounded capability so that we generate data for training AIs that are physically grounded and accurate and or plausible so that we could have an enormous amount of data to train with. The AV industry is here. This is an incredibly exciting time, super excited about the next several years. I think you're going to see, just as computer graphics was revolutionized such incredible pace, you're going to see the pace of AV development increasing tremendously over the next several years.